Good morning, everyone. Guess we're in the afternoon now, aren't we? I think we're going to get started. A poll just popped up, just getting some insight about what role you serve in your organization. Just really curious about where people sit and what kind of work that you do. Today, we're going to be talking about from blueprint to browser, how New York State turns wireframes into working code. But first, some introductions. My name is Jesse Gardner. I am the director of UX research at New York State. I oversee the design system and accessibility teams. I was working in engineering management for a lot of large organizations before starting to work in government, but I transitioned over to civic tech in 2023 and really enjoy it. I'm going to throw it over to Leo Vogel, who is our lead UX designer on the design system team.
Hi, everyone. I'm Leo Vogel. I've been working in digital design for a little over a decade. What's kept me excited throughout this time is building systems that make design more scalable and accessible for everyone. Right now, I'm the lead UX designer for the New York State design system. My role is to collaborate with teams across disciplines, including design and computer programming, so that the 97 state agencies can deliver more consistent, usable digital services. In short, we're building tools that don't just look good in Figma, but actually help millions of people get access to government services in a more modern, accessible way. Before this role, I spent time in the private sector at startups. I designed web-based ticketing platforms for universities, and I worked on AI-powered tools that help citizens and governments communicate more effectively. Across my career, the through line has been bridging the gap between design and development and advocating for accessibility so that digital services actually serve the people they're intended for. My experiences in the private sector prepared me for the challenge of designing for the 20 million residents of New York State. I believe technology should work for us. We shouldn't be working for technology. And even more importantly, technology should be designed for everyone and accessible to all.
I am so excited to see everybody reporting in from all these different places. It's really exciting to see folks from all over the place. Hello to the fellow New Yorkers saying hi. I am excited about this session, but there's a fair warning I want to give you ahead of time. This talk is going to include some technical information, but what we've tried to do is really ground it in delivering real value. So if you start to feel a little bit overwhelmed, feel free to ask questions in the chat. We'll be looking through that and answering some questions at the end. I think we'll probably have about 10 minutes of question time at the end. But don't lose heart, please. We've got a big list of resources that we're going to share with you at the end that goes into a lot more detail about how you can learn about the technical implementation of some of what we're talking about today. In the description for this session, I mentioned PDF specifically because traditionally forms have been delivered by governments via PDFs, and they exist because they're portable, they're easy-ish to use. They are somewhat easy for people to build, and they're relatively simple to just upload and consider it done. But we have some things that we'd like to share with you today that we think will make designing and developing web forms, which are far more usable, mobile-friendly, accessible, and just overall easier to use, faster to build than PDFs. But before I do that, I want to introduce you to something that we've been working on in New York State. Now, this talk is not about design systems, but a lot of what we're going to show you today is really built on the foundation of design systems. So I want to take a few minutes and explain what it is. And that way, as we talk about it, it makes a little bit more sense about the work that we're doing. Now, the way that we typically describe this to teams internally is we say something like the New York State design system helps teams rapidly build usable, accessible, mobile-friendly web applications and sites. And that's true, but it's really more of like a value proposition, and it doesn't really explain what it is. I'd like to talk quickly about what it is, but before I do that, let me share a slide with you that might help you better visualize why it was built. So Exhibit A is what I like to call the State of the New York State button. So when our team first started, we visited a few dozen New York State web applications and websites, and we found as many buttons. And as you can tell from the slide, different styles, different behaviors, different accessibility risks. And this type of fragmentation isn't really anybody's fault per se. It usually just is something that happens because different teams are solving the same problems over and over again in their own contexts, with their own business logic, with their own limited time, expertise, and capacity. And each one of these buttons took time to design. It took time to build them out. And even if you just said that each one of these represented one day of combined work between design, development, testing, if you were to multiply that out, that's almost a month of time just on this screen alone, just one component. So our team's mission was really to help create a standard library of UI elements. And so that's why we created the New York State Design System. It's really a connected system of UI components, design components and code components, using design tokens to build those out that exist on both, accessibility standards, usage guidelines to really help teams be more efficient in what they're building. And the design system really is made up of what we like to call three core pillars. We've got our code component library. We're using web components. We have our design prototyping library. We typically use Figma. And we have a design system reference site, which I'll share with you in just a bit. We have a team that's dedicated to this, but I'm going to let Leo talk a little bit about that.
So our dedicated team launched the first version of the New York State Design System earlier this year. We're still in the early phases of integration, but we have strong design adoption and growing dev adoption. We're now coming up on the team's 1-year anniversary. In the short amount of time since we started, the team has already won an award for the great work we've been doing. In the past 5 months, over 13,000 form elements from the New York State Design System have been used by New York State employees to build forms. One team saved over 60% of time working on a project just by using the New York State Design System. Just yesterday, a designer messaged us that this saved them 35 hours on a recent project. We're excited to share some of that work with you today and hope that it will inspire you to integrate these ideas into your own design system.
So our talk revolves around two big innovations, two big ideas that we want to share with you that make it easier for us to go between whiteboard, design prototype, and code. Now, I'm going to talk briefly about this first big idea, but before I do, I just want to reiterate something that Sandhya posted in the chat. If you have a specific question that you want to ask, please go ahead and click on Q&A in the right-hand side, and you can add your question there. It makes it a little bit easier to find questions as people chat. So our first big idea that we wanted to share is something that we call fidelity mode. One of the things that our team likes to do is we use whiteboarding a lot. We do a lot of wireframing because government forms are often very complicated, and whiteboarding is a great place to do a lot of sense making. And we like to bring people in like business analysts, leadership, policy experts. But we have had some people actually push to skip that step because they're pressed for time and they view designing both low fidelity and high fidelity prototypes as a lot of duplicate work and want to avoid that. And so in order to address this, we actually developed a way that Leo's going to talk about that we can toggle between low and high fidelity modes using a single set of Figma components. And so we've got sticker sheets of wireframe form elements in FigJam. And we found that FigJam is actually it's less intimidating for folks and frankly less expensive too, because the license for a FigJam user is cheaper. So it's an easier way to get non-designers in for collaboration. But then designers can easily copy and paste those wireframes into Figma and switch those to a high fidelity mode without duplicating work. And what this does is it lets people participate, people who are usually or sometimes intimidated by Figma, participate in the design process earlier while still having the contributions programmatically connected to the design system. And that's going to become important when we talk about the second big idea. Long story short, This approach frees us up to do a lot more time with early wireframing, where a lot of the important untangling complexity happens. And so to tell you a little bit more about fidelity mode and how it works, here's Leo.
Earlier this year, I attended a talk by designers from the Riva Digital Design System team. They spoke about how to use the technique of routing layers for the design decision variations of a multiple brand company. In the New York State design system at the time, our decisions were built in a two-tiered system with a foundational layer and an applied layer. Some call these primitive and semantic. Form elements are built from the top layer. The talk by Riva's design system team introduced me to the idea of adding a middle routing layer for design decisions. This gave me the idea for adding a routing layer that provides control to set the fidelity of the screen. Our human-centered design team previously built a robust wireframing kit for our whiteboarding tool, FigJam, with clear guidance and UX best practices for forms. The design system team built on top of this existing project by swapping out the sticker sheets of components with design system components set to low fidelity. If you're familiar with Figma variable modes and FigJam, you may be wondering how we did this, as FigJam doesn't officially support changing variable modes. Well, we came up with a simple workaround. We set the fidelity on a section in Figma and copied that section into FigJam. Let's see a quick demo of how fidelity modes work in practice. So you'll see here, this is the sticker sheet built by the human-centered design team with guidance, best practices on how to create forms, and a sticker sheet of form elements that you use to create a form. Here, I'm going to create a simple form for signing up for an email newsletter. I can drag and drop each of the form elements for my form in from the sticker sheet into the screen on the right. I can put them in the right order, and I can even click into them and customize the text. I can change the button from saying button to submit. And I can use features of FigJam to easily align things and rearrange them. FigJam is a much simpler tool, and it's a lot easier to use than a full feature tool like Figma. So now what we can do is we arrive at something like this, and we can right click on the screen that we've finished wireframing out, copy it, and then paste it into Figma. And then instantly it changes into high fidelity, a pixel perfect mockup, just through the power of the design system and the routing layers. You can change the theme, you can change the brand, you can change which device that you're looking at. Is it mobile? Is it tablet? Is it desktop? And we can go back and forth between different fidelity layers. We can go back down to low. We can change the fidelity font from realistic Comic Sans to more of a scribble. And we can change back and forth between the different fidelity modes. We can switch back and forth between different screen sizes. Everything just responds automatically. It's very fast and easy to customize the screen to the use case that you need. You can also switch into development mode and take a look at one of the form elements, like this alert that was customized in the FigJam whiteboarding tool. And all of that customization, the text that you type, will show up in the code that was handwritten. We'll get into that a little bit more later. So that's a quick demo of fidelity modes and how that works. It's really exciting. So again, here's a newsletter sign-up form to get updates about the design system. And with one click, you can change it from the grayscale sketch wireframe appearance to a full-color realistic mockup. And again, this is all made possible by the design system, which includes form elements built from semantically meaningful design tokens. Well, what is a design token? Components, form elements, like the text input field, are the UI elements that you use to build a form. These form elements are built from design tokens. A design token is a tiny design decision. It's like a small piece of design information stored in a variable container. If a design decision is paint, then a design token is the bucket that you put it in. What we're doing in the routing layers is we're changing what the design token definitions are. This is done at a middle layer that people outside of the design system team don't need to see or think about. Let's see how this is set up in a little bit more detail. So our design tokens are built in a 3-tiered system. There's a base layer at the bottom where we define the granular values of all design decisions that are applied to a form control, such as the colors, the sizes, and the fonts. Then we have the middle routing layers. In the middle layers, we have design tokens that vary. The routing layers have different modes depending on the visual theme that we want to use. And we can add more routing layers as needed to provide more visual options. Then at the very top is the applied layer, which contains the design tokens that we build the form elements from. Let's look at an example by focusing on the background color design token. The first mode is the default. So we will start with a realistic mockup in brand A. Watch how this simple button changes based on the modes selected in the routing layers. Here, the background color is red because it is set to the brand color, which is set to the primary color design token in the theme layer. Remember that the first mode is the default. So by default, the button's background color is red. If we switch the theme routing layer to brand B, then the background color changes to green. If we switch the fidelity mode to low, then the background color changes to gray. But notice that also the font and the radius have changed. With fidelity set to low, the theme routing layer isn't used. We're not referencing it. And if you switch back to the high fidelity, the button's background, radius, and font all instantly switch back. So in the New York State design system, we currently have 2 routing layers for theme and fidelity. In the future, we could quite easily add more routing layers as needed to provide more visual options, such as a dark mode or a high contrast mode for accessibility. In practice, this makes it possible to sketch out a simple wireframe of a screen in a whiteboarding tool that can use design token form elements, and then copy it into a design tool where you can instantly change the screen from a wireframe sketch into a high fidelity mockup. You can also set up different brands as we were looking at before, as we have, and instantly switch a screen to a different brand, making it possible to easily repurpose a commonly used form pattern from one project to another. And at any time, you can switch from a realistic mockup back to a sketch appearance if you want to get feedback only on the basic layout of the form, or set it to show text to get feedback on the text content without people being distracted by colors and images. And then switch back to pixel perfect mockup to integrate that feedback and hand it off to your engineering team for development. I'll now hand it over to Jesse to talk about just that, how we're speeding up the transition into code.
Quick note about something that Leo shared. That approach might seem complex, but one thing to keep in mind is it's complex for the design system team. But when the people use it, all they really see is just a small set of tokens that get applied to components, and they have those options for the various modes that are introduced. So my first impression when we were discussing this was that it would feel overwhelming for teams, but it's not, because again, downstream, they only really need to think about those applied tokens that are there. Okay, so now we get into reliably converting screens to code using AI. The key word there being reliably. But before we dive into that, I want to make a quick note. A couple days ago, I actually came across this post about wireframing by Ben Snyder, the senior director of design at ServiceNow, and his post prompted a lot of comments about wireframing. But there was one comment in particular that jumped out to me that was very relevant to what we're talking about today, and it was from Chris Haas. He was talking about wireframing and whiteboarding, and one of the things that he said, he made this interesting aside about how vibe coded ideas getting past design and getting approved by leadership was a real struggle in tech companies right now. And the reason I wanted to share this, because I believe that the approach that I'm going to share with you today enables some of that speed and efficiency benefits that vibe coding does, but it provides a more controlled and structured expression because it's driven more by an intelligent system of connectedness through design and development rather than just AI generation. So back to this. Whenever our team innovates, one of the things that we like to do is we like to start with the question. Sorry, I just somebody's comment about Figma Make. You have my deepest sympathies. So whenever our team innovates, we like to start with the question, what are we trying to help people accomplish? And you saw with a button slide, one of the things we're trying to accomplish is consistency across multiple, New York State agencies. But similar to the LinkedIn posts, a lot of government teams are under the same kind of constraints. They're under pressure to deliver faster, tighter budgets, especially in this day and age. But they still need to meet certain expectations. They need to be accessible. They need to be usable. Um, One of the most extensive steps in that process is going from design to front end code. And that often means that developers are recreating UIs from scratch or taking something that they currently have and trying to make it look in the browser similar to what is being, designed by the designers in Figma. I mentioned before that we tried to reduce that friction in handoff by building out the design system, and that has been a good start. But the approach that I'm about to share with you speeds up a very specific use of AI. Specifically, it's using it to stitch together accessible form elements based on real code snippets that are coming from Figma's MCP server. So let's walk through how we set this up and how we give AI the structure that we need. First, a few key terms, because I want to make sure everybody's on the same page. Don't know exactly where everybody's coming from, so I don't want to say some things that maybe you don't fully understand. So if you already know some of these things, great. I just want to baseline a little bit. So starting off with a term that most of you are familiar with, LLMs, large language model. This is an AI that has been generated based on a lot of data, and it can understand prompts, and it can generate structured output, things like natural language or code. IDE, if we have any developers in the chat, an IDE is something you're familiar with, integrated development environment. This is basically the software that a developer uses to write and to edit code. I use VS Code, many people do, but there's IntelliJ, Eclipse, many others. This is one that you may be less familiar with, but you will probably hear more about it in the coming years. MCP stands for Model Context Protocol. This was actually launched. This was an open source protocol that was launched by Anthropic, the company that makes Claude, about a year ago. And it's essentially a protocol for sending structured data to AI agents. I've heard it described, it's like the USB-C for AI. And I think that's a good analogy. This is a way to take, GitHub has an MCP server. So getting structured data about your commits or your repositories. Google Drive has an MCP server where you can get structured data about your documents and your files. There's a number of ones out there. More on this in a moment. GitHub Copilot is a specific tool. It is an AI-powered coding assistant that uses LLM, and it's often set up inside of an IDE. So, for example, I use GitHub Copilot inside of VS Code. And so this is beneficial because it gives your LLM the context of your code base. So, for example, things like the what files you have in there and what sort of frameworks that you're using, etc. And then lastly, Code Connect. Figma, this is a Figma feature that links design components to code, and it allows you to map things like variants and properties that exist inside of your Figma components to what exists inside of code. And I want to start here because this is one of the key building blocks for this particular approach. So Code Connect gives us a bridge between design and dev through mapped components. So say we've got a Figma button. This is our New York State button. It is FormFest purple. And the props that you would see. So if you were to drop this onto a Figma page and you were to select it in the right-hand sidebar, you'd get all of these options. And these have been set up by Leo and Kristen on our design system team. And we have options for size, for variance. You can change what the state looks like. You can set it to be inverted. There's a toggle for disabled. You can put in the label text there. We have something inside of our code base. We actually have a file, nys button figma.ts. And by the way, I will be linking out to that at the end. So you'll be able to look at this and poke around at our code. It's all open source. But this gives you a peek into our Code Connect mapping. And you might not be able to see it, but this basically is the code for our component, for an NYS button component. This is what it would render. And so all of our props get generated. This is what you would write if you were going to put something into an index.html file. And we use web components, but you could, this is just as easily could be React, it could be Vue, Angular, it could be a lot of different things. But the key here is that this file allows us to map what's in our Figma file, in our Figma components, to our code. And that then gets passed to Figma so that it can actually show the actual working code based on what a designer has set up and configured the component to look like, so that when a developer copies and pastes it into a browser, it actually looks the way that it's supposed to. And what's beneficial about that is we built a lot of accessibility into these web components that we've created. So this is great because devs can actually bring up dev mode and they can actually take a look. So here's our alert component and it's been set to info intent. It has a spot where you can put in the heading, the text for the heading, and you can see that in Figma, so a developer can look at this and see the live code. And if they were to change that dropdown, that code snippet would get updated. And this can also get brought into Figma's VS Code plugin, so you can have code completion as well. Very, very powerful from a development standpoint. And so this was our original intention when we first set up Code Connect. But as they say, luck favors the prepared. And having Code Connect in place actually set us up so that when Figma announced the MCP server, which was just a couple months ago, it allowed us to then take advantage of the fact that these code hints, which were accurate, were actually getting passed along, could be passed along to an LLM. So let me show you this process, and I will give you a demo, I promise. So let's say I've got a new screen that Leo designed, and I'm a developer. He sends me the URL for the Figma design, and I can bring it up in Figma. As a matter of fact, I would need it up because you need to have Figma running in order to have the MCP server working. They just announced a remote version of this, but I'll cover that another time. So we've got my IDE up, and my IDE is running GitHub Copilot. So what I do is I have a simple prompt that says, generate HTML from this Figma URL. It's a bit more complicated than that. I'll share it in just a bit, but essentially that's the heart of it. I put this prompt out there. And so GitHub Copilot says, well, okay, we have a Figma URL and you've asked me to put together code, and it sees the Figma MCP server and it says, oh, we have some tools available to us. We have Get Code, which is one of the tools that Figma's MCP server passes along. It has things like get a screenshot, get the variables that are used to build this out. And so it makes that request. And then what happens is Figma actually will pass in those code snippets back to GitHub Copilot. And then that gets passed along to AI. And so in a nutshell, AI gets full working code blocks, which greatly reduces the code that it needs to generate, the code that it needs to actually try to create. And that's really beneficial because the AI in this case is really just stitching those things together, and it doesn't have to do a lot of processing or generation. Maybe an unlock here, if you feel like this is a bit over your head. An unlock here is if you could think about this like a mail merge. So developers set up the fields, and then designers, through using components, are actually like entering the data. They're making those choices. And then Figma is just basically saying, we're going to take what we know has been entered in by designers, we're going to pass that along based on the mapping into the code snippet, and we're going to hand that off to AI. And the result is you get a lot more reliable output. You see, there's a kind of common approaches in a lot of teams that I talk with. They lean too heavily on AI generation, which ends up having the AI do a lot of guessing, a lot of generation, which gets you a lot of inconsistent, unpredictable results. And so what ends up happening is you get AI generating code much more on the sort of guessing side of things. And so, just as an example, this was code that was generated from our NYS global header by passing in a picture and not giving it any specific instructions. The code technically works in a browser. It's a bunch of Tailwind classes, but there are a few challenges with this in that repeating that over and over again is challenging. It could be generated in different ways. So the output might change depending on different contexts. And so what I like to call our cheat code, our approach to this is that by pointing a design in Figma, or by pointing at a design in Figma that has design components that have been carefully mapped, so you have human-directed code mapping, it gives AI the structured content that it needs in order to generate the consistent, accurate code output from designs. Now, I want to pause just for a moment, too, and say one other thing. So I've spoken with a lot of different design system teams, and there's a growing push to build MCP servers just for design systems and specifically inside of the code component libraries so that an engineer could jump in there and make a request to the design system code library and skip the design step altogether. GitHub just released their MCP server for their design system just a couple of weeks ago. But this brings us back to the challenge of AI generation. Unless those MCP servers are connected to design systems that have well-defined, well-structured ways to communicate those patterns, the like best practice patterns, the ones that work for people, the ones that achieve the outcomes that user researchers have identified. If you don't have that built into the design system, then the mapping that the AI puts together may not be that reliable, and the likelihood that AI gets it wrong is going to be much higher. The other thing that I'll mention is that this approach that we have keeps designers in the loop. And I think that especially at this early stage of this technology, it's really important for designers to be there because everything is anchored inside of Figma, especially in government. We desperately need designers helping make sense of complicated requirements, complicated policies, boiling down complex languages, and helping understand complex systems. And so basically this setup, this approach puts us more on the side where the AI is not doing a lot of guessing. It's just assembling code that we've already created. All right, so I promised you a demo. I'm going to give you a demo. Wish me luck. So give me just a moment to share my screen. Live demos are always a lot of fun. And so I'm going to share this screen. And first of all, I'm going to, yes, thank you for the 4-leaf clover in the chat. So again, this is a something that I was able to grab from Wireframes. This is all made up of the design system components. You can see in here our UNAV header, our text input. These are all the form elements that make up the this particular screen. And if I were to copy this, well, first, it's important that you turn on the MCP server. There's an option there for anybody who has Figma installed. But I select the desktop, this screen that I've created. I click on share, and I copy that link out. And then what I'm going to do is I'm going to switch over to my VS Code. And you'll notice I have a prompt that's written here. I mentioned to you that I had the prompt was a little bit longer, but at its heart, it's essentially generate HTML from this Figma the URL and use the New York State design system. I give it a few things to do. I say, take a screenshot, make sure that your output matches that screenshot. Don't use Tailwind because we don't use Tailwind. There's a couple of things like that that are in there. We also say use our components, just a couple of simple things. And then one of the things that's hard about Figma is layout gets tricky. And so we have utility classes for achieving layout. And so we have some of those directions for the utility classes. Normally you can put this and put this into an instructions file. I'm actually going to copy it out into a prompt just so that you can see how it works. So I'm going to go into an index.html file. The only thing that's here is our NYSDS CSS file and our JavaScript file. These are, we publish them, and they're everybody can pull those things down. These are publicly available, so there's no custom CSS that's going on in here. And so I'm going to paste into my GitHub Copilot. And one thing I just want to point out to you, a couple things actually. I can select whichever model I want here. I'm using GPT-4o here. You can also set it. It's important to use agent mode because that gives it more control over VS Code. But then importantly, I'm able to configure tools and say, hey, I want you to have available to your disposal the Figma local MCP server that is set up. And by the way, I will link to instructions on how to set it up. It's relatively easy, but we'll have that in our resources slide. And so here's that prompt, and I'm just going to run it. What might come up is it might have a fit because I don't have the Figma window open. You have to make sure that you have that open, but it worked. So that's good. It must be still running in the background. And so you can see it went and it generated the code. And this is not a lot of guessing. This code is actually specifically coming primarily from those code snippets that our designers and our developers worked together to collaborate. And all I need to do is say, apply this to the editor. And you can see it updates there. And I am going to bring this up into a live window. And there it is. And there's a couple of things here that aren't quite right. Some of the layout changes are a little off here, but a couple of things that I'll mention there. One is it's important to have an engineer doing your auditing of this, but it does save a lot of time. The other thing that I'll point out too is that I had it generate the entire screen, but as we were doing, as we do a lot of this work, one of the things we realize is, especially if you've got 50 screens for an application or a really complex form, we don't necessarily need to select the headers and footers. Those are going to repeat on every page. So we could do something as simple as selecting that inner area and having it just generate that. So it ends up becoming an even a smaller payload there. So again, hopefully you've been able to see how this can be something that could be really useful for generating specific output using AI, but not in a way that you run the risk of it being wildly incorrect, but you actually get a lot more control over the output. Yes, and thank you for all who wished me well. It did work. And now to wrap up, I'm going to ask Leo to share a little bit.
Thanks, Jesse. Let's just pull up our slide deck again. We've had a couple of questions in the Q&A that I've had a chance to answer. We'll take a look at Sana's in a moment. Okay, so today we showed you a technique to instantly transform wireframes into high-fidelity mockups by using a token-driven design system. We built this innovative approach to help save us countless hours, reduce our cost to build forms, and remove a major pain point of resistance from leadership when it comes to starting from wireframes. We really hope it inspires you. In part 2, we showed how these mockups can be converted into accurate code with AI using a human-crafted template integrated into the design system. This second innovation drastically decreases the time to build modern, mobile-friendly, accessible web forms. If you're working on a design system, please reach out to us. We'd love to hear from you. You can email us at designsystem@its.ny.gov. And before we wrap up, we'd like to share our session resources page, where you can explore everything we talked about today in more depth. The resources page is on the design system reference site, where you'll find our full design system documentation. The resources include my article that explains in detail how fidelity modes and routing layers work, along with a link to a Figma community file for fidelity modes that you can play around with. It gives you a simple playground to try out and explore the concepts. Other resources include the New York State Design System's full open source GitHub codebase, including all of the code that is human written for connecting all of our form elements to code, and the AI prompt that Jesse showed earlier for how to generate the code. We also have a video series that walks through the concepts of the design system. And looking ahead, we plan to publish our full Figma design system library so that you can explore it in full detail. Once that's live, we'll add it to the resources page as well. Finally, if you'd like to go even deeper, there are links to learn more about design systems more broadly. So definitely check out this page after the session.
All right. Somebody flagged that the FormFest slides link is broken on the page, and that is correct. We'll get that updated as soon as we are as soon as we're finished here and we get it uploaded. So I hope what we've shown you, I hope we've been able to get you excited about what's possible when you combine a really well-structured design system with the right tools and some creativity. I want to just leave you with a parting thought before we jump into some questions. I recently came across a piece called The End of Civic Text Interface Era by Dan Muntz. And he talks about the rise of just-in-time interfaces, basically things like chatbots, wizards, dashboards, any place where you would have a UI that adapts dynamically to a user's needs or a particular context. And I just want to say that that kind of flexibility only really works if you have a solid token-based design system underneath it. And that same token structure is what makes the fidelity modes that we showed you work. And it's really what gives the GitHub Copilot enough context to generate reliable code from Figma files. I know that there's a lot of upfront cost to structuring it this way, but we've experienced that the long-term payoff, and again, it wasn't a whole long time, but the long-term payoff is faster delivery, better accessibility, happier handoffs. And if your leadership team needs a little bit of convincing, just send him the recording of this video. I also want to say you don't have to start from zero. You can start with components that your development teams already uses. We're going to link you to Figma has a simple design system with React code already connected with Code Connect and a community file, and it's linked in the resources. You could fork ours if you want to. I just want to leave you with this idea that we started off kind of casting shade a little bit at PDFs, and one of the reasons why they had such wide adoption is because they're fast and they're familiar. But we want to make sure that easy to make isn't the only bar for success. What we've shown you today gets you a lot of the speed of vibe coding, but it gives you much more reliable output that really government services need. And so at this point, we'd love to pause for just a moment and take some of your questions. Maybe one of the things I can start with, someone asked the question, how did you get engineering support for this? And a couple things to mention. First of all, we are relatively young in terms of our design system. We just launched earlier this year in March. And so we have much higher support in terms of adoption on the design side, but design is a leading indicator. A lot of the times the design then gets handed off to development. I think one of the biggest, so we're still working on engineering support, but I think one of the biggest things that I think was helpful was we have a lot of folks who are who have a lot of back-end development or sort of that middle layer where they're good at the routing, the authentication, the database connectivity, API. And so it's hard to stay on top of accessibility. What's best practices in terms of accessibility, CSS, media queries. Sometimes it can be the front of the front, the front of the front end and the back of the front end can be a clear division. And so being able to provide teams really quickly, this is going to give you like a supercharged start, has been kind of an appealing thing for teams. I'll also say too, we are in the process of working on building out from web components to wrapping them in React, a React library in Angular, so that the teams that need that can have that available to them as well. Great question though. Does the generated code include all of the interactive behaviors, focus, error handling, etc.? So the answer there is yes, it does. And the reason why it does is because we built that into those code components. So that's one of the reasons why that drop down, you didn't need to change state, because that state was something that we did design. Leo puts that together, but then the engineers are able to take a look at that and say, this is what it should look like. And they build that state into the styles for those components. So Figma doesn't really need to actually do that generation.
How long did it take you to set up all the tokens and components? Well, we got started about a year ago in November of 2024. And we released our first version, was it April or so, our 1.0. So it took us about 6 months to get to a first release. But a design system is a living, breathing project. We have a dedicated, permanent team. This is not a 2-year project. This is a permanent project that is meant to serve all of the teams at New York State that are building digital experiences for the 20 million residents of the state. So it's really important that we do have this permanent dedicated team, and it's an ongoing, evolving process. And we have a really great component process that maybe Jessica could talk about, because that was one of the other questions.
Yeah, I think we're about at time. Let me answer just two together, and then we'll probably wrap this up. You can reach us on that email if you have further questions. But two questions that I wanted to talk about. One is the size, maturity, time frame. So the size of our team, we have 2 UX designers, 2 developers that are primarily focused on front end code. We have a team lead, and then we have somebody who's doing product coordination, so working with the various teams to understand what those needs are. And so at a high level, the team is really young. A lot of folks came from the industry to help build this out. The time frame was, like Leo said, we started in November. We launched our V1 with about, I think, 15 components in March. And every month we've been releasing additional components. And we really think we've gotten to that kind of critical mass of components. Somebody asked about under review status with components. We actually have a really solid, if you explore our code base, we actually track our component proposal process where people can actually propose and we can get feedback from teams. So we have a really solid process that you can read through the detail there. We work very closely with our experience design team that does a lot of the user research. So I like to say to our teams, we are not the innovators, we are the curators, because there's a lot of really good work that's going on. And so what we try to do is ask those teams, what are the patterns? How do we want to standardize this? Because a lot of teams doing the work don't have times to standardize this. And so we come alongside and say, what was your intention here? How can we standardize this so that when you use this again, it feels like it's exactly how you want it to be? Because our ultimate, like our first line customers really are our production teams, the people who are doing design, people who are doing development. It's the second customers that are the New York State residents that experience the work that those teams that are building build out. All right, we are at time. If I didn't get a chance to answer your question, thank you so much. I appreciate you being here and taking time out of your day to enjoy the session. And hopefully we'll be able to connect and talk a little bit more. Thanks again.
Thanks, everyone.